Do I need to do the next one?
No.
We can share our answer.
Okay.
In fact, do I even need to do the next two?
We know
Yes.
we did this in exam prep 2012, 2013.
Yeah.
All of these.
Yeah.
And what was the problems then?
The only problem was that one for adding n to b equals theta.
The last question, the A8.
The last question.
The last question on what page?
A8.
Huh? Oh, down here.
Yeah. The I bet the B equals and then
Adding the n. Here you have to add the n. Because they said linked with the coil, not linked with each term in the coil.
but the A5 is harder to do.
A5? Which A5? On what page?
48. Page
48, A5. Ah, yeah. We can do that one. I've noticed a mistake here on page 49. For some reason I have a wave question up the top there.
Oh yeah, that one.
What is that doing there? That needs to be moved. Can I take your pen just to move this? I don't know how that's in there. Will we do A5 then on the next page?
Okay. Before you do A5,
Yeah.
it's just honorable mention that
Yeah.
in page 47 the question says magnetic flux linked with the coil, not with each term in the coil. That's why we added n.
That's now total. Yeah. Yeah.
I see that for you.
Huh?
I see that for you.
Which one?
Page 47, the last question that part 2 asks, okay, magnetic flux linked with the coil. So this time you add n number of terms.
Can we look at
But it's the same as the last one.
No, the other one says linked with each term in the coil.
Oh.
yeah. What page 48 A5. Okay, so a copper rod 1 meter in length, pointing east-west, is dropped from a height of 20 meters. Yeah?
Yeah.
Now, which way is the magnetic field? The magnetic field for Earth, if I try and picture it, hang on, that's actually south, that's actually, so it's the magnetic field goes pointing to the north. So if this is east and this direction is west, then north is straight ahead. So in the picture, the magnetic field is going into the page. So the magnetic field is like this.
Do we have to know the direction?
Yeah, it's good to know it.
I mean for the question.
1.8 times 10 to the minus 5 Tesla. Anyway, the first question is how fast is it going when it hits the ground? Which is just a UVACS problem. So the U is 0, the V we don't know, the A is minus 9.81, the T we don't know, and the S is minus 20. Yeah? So we have V squared equals U squared plus 2AS. So what's the square root of 40 times 9? About 20, 19.81 meters per second. What? 3 marks?
Yeah.
You didn't even think of UVACS.
Yeah, I never think of UVA.
Oh, come on. Now, next thing is to calculate the current. The voltage. So that's minus n delta phi over delta t. There's only one, so the n is 1, and I don't actually care about the minus because I really don't care if the current is going left or if it's going right. I just want to know the size of it. So that will be equal to delta phi over delta t, which equals delta BA over delta t. Now, which is changing, the B or the A? Yeah, as this falls, it's actually the A that changes. So that is B delta A over delta T. Now, how can we get the delta A? Well, yeah, we could, there's two things we could do. But really, it's quite normal to look at this as a per second. Yeah? So in 1 second, what is it? Well, I have a feeling that because they asked me to get this, they want us to look at using this. But, okay, there's two problems I have in my head. Let me explain them. First problem is this. If I want to calculate this, if I look at the start, in 1 second, that would be smaller than the area per second at the end. Why? It's moving faster. So, I feel like I should be using the average of the two. So at the very, very, very beginning, it's kind of like a 0 meter squared per second. And at the very, very end, it's 19.8 times 1. So at the end, it's 19.8 meters squared per second. So I think it's wrong to use this because while it's fallen, it's not fallen as quickly as this. And of course, it's obviously wrong to use 0 because it will begin to fall. So I think the average should be used.
Teacher,
Yeah.
if the velocity is so hard to determine, why not you just find the t and then the whole thing?
Well, that's now see because remember I said I have two problems. So my first solution, or my first problem is, do I use this? My second problem then is, should I consider the whole area, the whole journey, and divide it by the journey time? Let's see what answers we get, and then we'll check. Now let's just see. So, first possible answer is this. What's the B? 1.8 times 10 to the minus 5 times 19.81 plus 0 over 2. Yeah? Let's see what we get. 1.8 times 10 to the power of minus 5 times 19.81 divided by 2. So my first answer is 1.78 times 10 to the minus 4 volts. Now, let's do what Lee just suggested, which is to look at the whole journey. So that's 20 and that's 1, so the whole journey here is 20 meters squared. And we should work out the time here. V equals U, thank you Sean, plus AT. So the T is 2 seconds about, yeah. So that means I should be using 10. It's about 10 per second. Would you realize, oh, that's actually kind of close anyways. Or could it be this? 1.8 times 10 to the minus 5 times 10. I think this could be 10. So that is 1.80 times 10 to the minus 4 volts. So in fact you can see that it actually doesn't really matter so much because the difference is only 0.02 times 10 to the minus 4.
But not if the distance long. I mean the first one has a lot of error. But
What
you
about the
should.
formula given in the formula with VLV?
Very good. What about the formula in the formula book? So say that formula then.
V E equal B L V.
Here's the question. What V do you use? Do you use the V at the end?
Yes.
Or at the start? Or in the middle? Because the V keeps changing. It's increasing.
So we take the average.
Yeah, so if you do that, you're kind of doing it like this way.
Huh?
Well, I would be very curious to know what they decided to do in the marking scheme. What did you choose to do? I'm guessing you probably just used BLV. Yeah. Now this makes the answer bigger than it should be because you're using a big V, the V at the end of the journey.
Because it's too much.
No, that's actually, I can see this is the right answer here. Listen carefully because it's something they said in the question. Listen. Lee, are you listening? Determine the voltage across the end just before it hits the ground. Just before it hits the ground. So this one is the answer. Yeah, whereas this answer here, this is like an average. Oh, you could use this. If you use that, you'll get this answer.
No, double.
Oh, sorry. I'm very sorry. Yeah, I forgot I took the average for that one there. Yeah, so it should be, as you said, Sean, double it. Yeah. So it's 1.8 times 10 to the minus 5 times 19.81. Yeah. So you're looking at the last part of it. And this because the question said just before it hits the ground.
Also, it changes all the way down.
Yeah. So, Lee, these two numbers here is kind of like the average voltage as it's fallen, but it reaches its peak before impact, which is actually what they want. So they could have said what is the maximum voltage, because that would be just before it hits the ground. What if they wanted the voltage as an average for the whole journey? They might actually say what is the average voltage across it. Okay. I had a feeling though, because it's only 2 marks and they just asked to calculate the V in the last question, like, kind of makes sense.
So what is the formula for EMF? Oh, V.
I don't, looking at the rest of the questions, other than this one, there isn't anything, yeah, which page? Yes. Yeah, which page? A6? A8? Yeah? Yeah? No, she wants 48. Last question. What's wrong with it, Monica? Okay, well, if you do know your question, you can ask me. Yeah? Are you sure? Yeah, so plus 2. Yeah. 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 It's alright, isn't it? else do you need me to do from fields? 'Cause I'm looking at the rest of the questions. There's nothing, like there's transformer, which we've done. There's the mass of the moon, which we've done, using Kepler. There's, you know,
But we still got a question.
Lee, will you
No.
stop annoying me?
I have another question.
Yeah,
The A4 on page 49.
yeah. That should be in the wrong, that's in the wrong section.
A4.
Oh, 4, yeah. DC. Oh, sorry.
AD.
No,
Oh, sorry.
AC generator.
So when you draw the graph of this, so they ask you to draw a graph to show.
Yeah. It's like, right hand rule.
Yeah.
At the beginning, F up, B is right, current is in. The normal is at 90 degrees to the field. So if you think about the formula, this, now I don't care about the minus, so it's this, we'll figure out the direction in a moment, okay? Which is this. Which will be NBA, the change in cos theta over t, which is NBA sine. And it starts at 90, sine 90, but it's starting at 90. So actually I think the graph, if you draw, it looks like this. I think. Crazy. Oh, these generators can only make AC.
No.
Yeah.
I mean, the difference between AC and DC, even if we're still string
No.
we are not string
It's a rotating.
No. No, these generators can only make AC. They can't make DC.
How does DC generator look like?
There is no. We don't study DC generator.
We don't.
No. We study DC motor.
And
It looks like it, yeah. It looks like it, but the slip ring connection is different.
How can we tell from this picture? It doesn't-
Well, the question is, draw a graph of the EMF induced. So the DC motor would use a current to make motion, whereas they're asking you here what is the induced current, so meaning it was the opposite, motion was used to make the current.
And then AC is right hand rule.
This guy is right hand. No, or is it left hand? Ah, flip. Hang on. Left hand grip rule, right hand motor, left hand generator. Left hand rule for this one, I think. Yeah. Anyways, I didn't actually need the left hand rule. I just actually needed this formula.
I mean, you do because maybe they'll ask you which direction the current is flowing.
Oh, I do. Okay, sorry. So let me think. I need left hand. So F B R. Is it left hand? Is the current going B to A? Yeah, D to C to B to A. Yeah. Okay. Okay. Good. All right. Should we go on to another chapter? Are we finished with fields?
No, I have a question.